In a previous video I developed a 3D printed drilling jig to make accurate holes in parts for the injection moulding machines which I sell. This update shows some more jigs, and this time with steel inserts for improved accuracy and durability. This is a view of the injector barrel, and the next jig I made was the one which locates those two holes. The alignment of the bottom one is super critical because it holds the barrel of the injector in line with the piston, and if they're not very well aligned, the whole thing binds up. The holes also need to be very close together, but not so close that you can't tighten the thermocouple, so accuracy everywhere you look for these two holes. This was the first jig for that, basically a cylinder with two flats, one with the holes that you drill through and one without the holes so you can sit it on a column drill, and a flange at the bottom to locate the bottom of the barrel. In fact, this one didn't work very well. 3D printing things with sharp corners on the bed, as this one has, causes problems with lift and also with distortion, and those minor distortions would prevent the jig from sitting flat on the column drill table. Also, this version doesn't incorporate the stainless steel insert concept. Version 2 corrects these problems. The rounded corners on the bottom prevent the anomalies I mentioned. The insert space is there, and the rounded edges when you lay the thing on its side also helps with any printing imperfections, lifting the thing up as it sits on the drill press. This is the same basic concept and design extended to another jig. This one drills all of the holes in the column of the injector. The vertical gully running up that part is to prevent 3D printing artifacts making it difficult to insert the inserts. I modelled the bolt I was planning to use just to make sure that everything would fit. And there's a recess on the back of the jig for a washer which helps the bolt hold the jig to the injector's column. Turning the insert from stainless steel was a fairly uninteresting process. It was turned to fit the recess that it was made for, and here it is, job done. Little chamfers to help the fitting of the inset into its recess and to help the center drill into the insert when it's ready to do that. It's a nice tight push fit, and because all of the recesses are the same size, you can actually use the same insert for every hole. Or if you prefer, you can make as many inserts as there are recesses and perhaps glue them in place. Well, here's that test jig in use on the drill press. In this case, drilling a piece of scrap chrome plated tube, which is what the injector column is made from. The insert is made so that this particular center drill fits very snugly inside it, and that's what locates the hole accurately. After that, when you drill the final hole, it's the center hole which locates that drill. This is the jig for the barrel holes. Well, necessity is the mother of invention. When I learned I was going to lose access to the milling machine, I thought I was screwed on this. But the jigs are actually far more convenient. There's no other machine to use or set up or clean up afterwards. It's done on a drill press, it's de-skilled, there's no measurement, there's no looking at verniers, there's just, peg in hole, dug, dug, dug. It's that straightforward. So, a successful enterprise, I think, and job done. But before you go, here's a little something for you.